Are you struggling with ion chemistry? Let me show you the faster, easier way than struggling with memorization and flashcards and all the other ways. Here's the easy way. Look at this. That's the Ionic Bond Disc Model. Look at that. So if we look at this, this is a chloride ion, and that's the name of it. Okay, chloride. And here's sodium. It says Na because it used to be called natrium. Sodium ion. And we've got calcium ion. Okay. And then we have one where it's made up of 4 different atoms, a carbon and 3 oxygens, and all together it's called carbonate. So you guys probably know calcium carbonate because it's found in seashells and limestone. And of course you know table salt. But let's talk about ions first. First of all, an ion is an atom or group of atoms that has a positive or negative charge. An atom that has a positive or negative charge, or in the case of carbonate or other polyatomic mini-atom ions, they have multiple ions, multiple atoms that are stuck together. And overall, they have a charge, okay? Now, if you have something that has a positive charge, it'll be attracted to something that has a negative charge. And then you get something called an ionic bond. Again, let's look at the models and see how this looks. Let's start with table salt. Table salt is sodium chloride. So a bit of sodium metal, an atom with sodium metal loses an electron. That's why it has a plus charge. It has more protons with positive charge on the inside of the atom than it has electrons zooming around the outside somewhere. And chloride tends to pick up one of those extra electrons, and they're attracted to each other. Boom! Look at that. You have table salt, sodium chloride. They're attracted to each other. Simple. Okay? Now, let's say, on the other hand, that we have calcium. Now, calcium is also a metal. It's an alkaline earth metal. It loses 2 electrons. It's in the second column of the periodic table. It loses 2 electrons. And so it also will bind with chloride. Oh, wait a minute. We have an extra plus. We need an extra chloride. Boom! Now we have calcium chloride, CaCl2. Wow, chemistry is easy, isn't it? Okay, but now let's say that let's take this apart, and let's say now that we have calcium carbonate, like in seashells. Well, guess what? This has got 2 minuses, and here we have 2 pluses. Think they go together? Ah, they do. If I can do this with one hand, I always struggle with this. Go on, there it is. I got it with one hand. Calcium carbonate. Okay, if we turn it over so you can see it, it came apart. A tangled mess. Okay, and here we have it, calcium carbonate. Okay, calcium carbonate. Aside from my screwing up with the ions flipping around and whatnot, it's easy. The whole key to ionic compounds is that when you put them together, every plus has to be covered with a minus. Every minus has to match up with a plus. In other words, it has to add up to 0. It's that simple. Otherwise, it doesn't form an ionic compound. And ionic compounds are important in life, in all sorts of minerals. Okay, rocks are made out of minerals, many of them made of ions, and so on like that. The way your heart works is because of sodium and potassium ions moving in and out. The way your brain works, it's critical. And ion chemistry is actually pretty darn easy. All right, more later. Keep watching. Thanks.